Okay, so in this question, we have to work out the value of P when W is 70 kg and H is 0.65. We can see in this formula, this is a formula for Frida's power output, and the weight in kilograms is W and the height in meters is H. So for this first question, we want to know what the power output is when the weight is 70 kg and the height is 0.65. So P is equal to 36 times 70 plus 62 times 0.65 plus 1800. When we multiply all of that out, we end up getting 4,360.3. Okay, the next question. After 1 week, Frida's power output has increased by 8. Her weight has not changed. Work out the new value of H after this week. So the power output P has increased by 8. So here, the power output was 4,360.3. So her new power output is going to be 4,360.3 plus 8, which is 4,368.3. So we know from the formula that the power output is equal to 36. Her weight is not changing, so we're still subbing in 70 plus 62. We don't know what our new height is, so we leave that as H plus 1800. Okay, so 4,368.3 is equal to, when I multiply 36 by 70 and add 1800 to it, I end up getting 4,320, and then I'm adding my 62H. Okay, and then I'm going to bring this over to the other side and take it away. So I end up with 48.3 is equal to 62H. Dividing both sides by 62. These will cancel off. I'll end up getting H is equal to 0.779. We have to go to correct to 2 decimal places. So H is equal to 0.78. Okay, the next question. The graph below shows the value of P for different heights when W is 70 kg. The graph cuts the y-axis when P is 4,320. So when the graph cuts the y-axis, it means that x is equal to 0. So when x is equal to 0, okay, P is equal to 4,320. So that's 0 on the x-axis, the y-axis 4,320. We need to draw a graph to show the values of P for different heights when W is 80 kg. Using the same axes and scales. So state in the diagram the value of P where your graph cuts the y-axis. Okay, so what we need to do is go back to the formula, and this time we're going to sub in 80 for W. So we'll have P is equal to 36 times 80 plus 62H plus 1800. So P is equal to 62H, and when I multiply the others, I get 4,680. So we can see that on the x-axis, H is the x-axis in this case. So when H is 0, that will basically cancel out, and P will be 4,680. Okay, so I'll be marking P roughly around here, and that will be 4,680. And the line will just be a parallel line to where W is equal to 70, because in this case W is going to be equal to 80 kg. Okay, the next one, Frida finds a second formula for power output. She sets the two formulas equal. This gives the following identity where F is Frida's height. So we should use this to write H in terms of W and F. So we have to rearrange everything here. So we're just left with H's on the left and everything else on the right. Okay, so first thing I'm going to do is I'm going to circle 60W, and I'm going to bring it over here, and it's going to change signs. I'm going to leave the 80H there. I'm going to circle minus 15F. I'm going to bring that over there as well. And I'm going to circle minus 1300, and I'm going to bring that over to this side as well. Okay, now, so I'm happy with 36W on that side. I'm happy with 1800, but I need to bring the plus 62H over to this side. Okay, so let's have a look through it all. First one, 60W is going over there, so we ignore that. 80H is staying. Minus 15F is going over there. Minus 1300 is going over to the other side. Now, is there anything that needs to stay on this side of the equation? We can see that the 62H needs to be moved over to this side. So I'll put it in minus 62H. Now, on the other side, 36W is staying, 1800 is staying, and I'm bringing the 60W over. So I'll have minus 60W plus 15F and plus 1300. Okay, so when I collect the H's together, I end up getting 18H. So 18H is equal to, so let's collect the W's. So I get minus 24W. There's only one F, so that just stays as plus 15F. And then I can collect both of these together and I get plus 3100. Okay, now I want to get what 1H is, so I have to divide everything by 18. So all of this needs to be divided by 18 and they'll cancel off. So I'll just end up with H is equal to minus 24W plus 15F plus 3100 all over 18. So that is my answer. Okay. Okay, next question. A sheet is folded in half a number of times. H of x. So H of x also means y, the y-axis, and the function we've got x there is the x-axis. So fill in the table to show the number of layers. So I'm subbing in. You can see here that the number of folds is x. X is here. And the number of layers, all of this is equal to the number of layers. So when I sub in 1 for x, I'm going to get 2. 2 to the power of 1 is 2. Subbing in 2, 2 to the power of 2, 4. 2 to the power of 3, 8. 2 to the power of 4 is going to be 16. 2 to the power of 5, 32. And 2 to the power of 6, 64. Okay, then we have to list the elements of the domain and the range that are shown in the table below. So the number of folds, that's my inputs. That's what I'm putting into the function, which is your domain. Your domain are your inputs. So I get 1, 2, 3, 4, 5, 6 for my inputs. And my range is my outputs, what the whole function is going to equal to after I've put in my domain, which is 2, 4, 8, 16, 32, and 64. Okay, we then have to work out the least number of folds that will be needed to have more than 500 layers. So this number here, these numbers, I want to see what numbers do I need to put in for x for this number to end up being more than 500 layers. So we've done 2 to the power of 6. So let's have a look and see what 2 to the power of 7 is. We get 128. 2 to the power of 8 is 256. 2 to the power of 9 is 512. Okay, and there's our answer. We got more than 500 layers there. So the least number of folds is 9. Okay, we can't say 2 to the power of 9. It's the number of folds is just the x value. And just the x value in this question is the 9. Okay. Okay, so we have to work out the number of layers after 12 folds. So again, x is 12, which means we're writing 2 to the power of 12. Okay, 2 to the power of 12 is 4096. But we have to give our answer in the form a by 10 to the n. Okay, so this is what we would have done in applied arithmetic. And what we see here in the 4096 is the decimal place will be at the end of the number, the imaginary decimal place. We want to move it so that the number is between 1 and 10. So that decimal place needs to move between the 4 and the 0. We'll end up with 4.096 by 10 to the power of how many places the decimal moved, which is 3. And that's my answer. The next one, explain what the following statement means in terms of folds and layers. So we know, again, that the x is the number of folds. Okay, so what's usually in that bracket is x, but here it is 14. So 14 means the number of folds. Okay, and when there are 14 folds, there will be more than 10,000 layers. So that's the greater than sign, more than 10,000 layers. The whole function means the number of layers. So when there are 14 folds, there will be more than 10,000 layers. Okay, the next question then, put a tick in the correct box to justify what kind of pattern is made by the number of layers. So it's definitely an exponential, okay, because it doubles every time. The function doubles every time. We started with 2, then 4, then 8, 16, 32, 64, etc. Okay, the next question. After a certain number of folds, there are k layers. How many layers will there be after 3 more folds? Okay, so after a certain number of folds, we've got k layers. How many layers will there be after 3 more folds? We know from the previous question that to get the next number of layers, we multiply the previous by 2. So if we're getting 3 more folds, we're doubling, then doubling our answer, then doubling our answer again. So we are getting 8k. It's the same for the next question. After a certain number of folds, there are 2 p layers. How many layers will there be after 3 more folds? So doubling that, then again, and then again, and we're getting 2 to the power of p multiplied by 2 to the power of 3. But we have to write our answer in the form 2 to the power of m. So this is our rule of indices. When the base number is the same, and we're multiplying them, we add the powers together. So we get 2 to the power of p plus